This is my wireless setup, integrating motor control. As you can see, we have the geared motor and we have two servos, which will be controlled wirelessly using the NRF24L01 modules. The transmitter side will use two joysticks, one to control the gear motor and another joystick to control the servos. On the transmitter side will be powered by this power bank. On the receiving side, we have two power supplies, one to drive the motors and the other to power the Arduino Nano. To demonstrate, so now to control the geared motors, counterclockwise, clockwise, opposite rotation, another opposite rotation but in the other way, and for the servo, and for the other one.
I won't be discussing too much about the sketch since it's already available from Drone Workshop's channel on YouTube. But I will be discussing the modifications that I've done to the code. So we include the necessary libraries. Then we define the variables that we're going to store the inputs. Aside from analog inputs A0 and A1, I've added analog inputs A2 and A3. Then we set the initial values in the middle, which is 512. We have 2 bytes for motor speeds plus 1 byte for indicating directional control and an extra 2 for the servos, so a total of 5. So basically this follows the sketch from Drone Workshop until we reach this part. So we declared 2 more motor control values that we'll be sending to the receiver to control the servo motors. Motor control 3 to control the tilting mechanism, and motor control 4 to control the pan movement. So these variables receive values from 0 to 1023, and we map that value out to 0 to 255. So basically that's all I modified on the sketch. Do take note of the pin assignments for the NRF module. On the receiver side, we've included the library by Andrew Davis of Brainy Bits, and I've included the I2C address of the PCA9685 module. Then we add a few more pieces of code. This assigns the value received from the transmitters, buffer 3 and buffer 4. So for the input pins to the motor driver, we've assigned pins 2, 4, and 3 as input pins for motor A, as input pins to control motor A, and 9, 6, and 7 as input pins to control motor B. Take note that E and A and E and B are PWM pins. We've also assigned a standby pin, which is pin 5. So here we declare the pins as outputs. Then we initialize the servo driver and wake it up from sleep. Then we select a channel for the servo module to operate the servos. So we assign pin 0 and pin 1. So for setting motor direction, we've assigned buffer 2 and another else if to make the motors move left and right. So this statement keeps the motor from moving with the standby set to low. So we write the values received to the PWM pins of the Nano, ENA and ENB, which goes to the motor driver. So this statement controls the servo, which is buffer 3 and buffer 4.
So here we have the Arduino Nano, the TB6612 FNG motor driver, the NRF24L01 wireless module, and a small buck converter to step down the 6-volt input voltage to 5 volts to power the servos. 6 volts goes directly into the VM pin on the motor driver, and another 5 volts supplied from the Nano to the motor driver also. You can either mount an ESP32 camera or something else if you like. So we turn on the transmitter and the robot car. So first we'll control the servo. Now we'll control the wheels. So going forward, going backward. So either way, left turn or right turn, the wheels will turn in opposite directions.